Here I'm going to go through Leaving Cert Maths 2020, Paper 1, Question 6, which is a differentiation from first principles. And before we start, we just need to expand the brackets. So this is going to be equal to 6x squared plus 12x minus 10x minus 20. So our function then becomes 6x squared plus 2x minus 20. So when we're differentiating by first principles, I would always say, just think about what your final answer should be. So f prime of x, at least then you'd know if you've gone wrong. F prime of x becomes 12x using our rules for differentiation plus 2. So I know that that should be the answer. And when we're differentiating by first principles, have a look at the video I've got on the website about how to do it using graph and things like that. We first work out f of x plus h. So basically what that means is if f of x is equal to this, then f of x plus h means that wherever you see an x, just replace it with an x plus h. So you've got 6 times x plus h squared plus 2 times x plus h minus 20. So we just expand that out. That's going to be 6 times x squared plus 2xh plus h squared plus 2x plus 2h minus 20. That gives us 6x squared plus 12x h plus 6h squared plus 2h minus 20. And then the next step, we need to subtract f of x from f of x plus h. So in this next step, we're going to have f of x plus h, and we're going to subtract f of x from it. So it's going to be 6x squared plus 12xh plus 6h squared plus 2x plus 2h minus 20. And we're going to subtract this from it, which is minus 6x squared plus 2x minus 20. I've just kept that in brackets there. So 6x squared minus 6x squared, so we've no x squared terms left. We've got 12xh, then we've got plus 6h squared plus 2x minus 2x, so there you go. So I've lost that. Then we've got plus 2h, and then we've got minus 20 minus minus 20, which is plus 20, so we've lost that as well. So we've just shortened it down to that. Next step then, we have to take our f of x plus h minus f of x, and we need to divide that all by h. So we're left with 12x plus 6h plus 2, which is what we get when we divide this by h. And next, or the last thing we need to do then, is find the limit as that goes to 0. So lim as h goes to 0 of f of x plus h minus f of x all over h. If you want to know what all this means, have a look at the video on calculus by first principles in video on RMC Study. That then becomes the limit as h goes to 0. So wherever you see a h term, you just replace it with 0. 12x plus 6 times 0. Because what we're doing there is we're getting as close as possible to that h being 0. Okay, so essentially the limit of that h going to 0 is just replacing it with 0. And we're left with 12x plus 2, which is what I kind of knew it was going to be at the start. Okay, so that's the differentiation by first principles. Remember, if it's in brackets or factor form, just expand out the brackets first before you do that. So the next question, h of x is equal to half the natural log of 2x plus 3 plus c, where c is the constant. So find the derivative of that. So we're looking to derive this function. So the first thing you're going to do is go to the log tables, and what you'll do is you'll find that the derivative of the natural log of any function x is just equal to 1 over that function x. So with that in mind, I'm going to use that part here to be able to answer that question. So that is going to be half of, well, it's going to be 1 over 2x plus 3. Now, the derivative of any constant c, we know there's no x term there, so that just becomes 0. Using the chain rule, because we've got a function within a function, we need to multiply this by the derivative of what's in the brackets here, which is 2x plus 3. And the derivative of that is just 2. So we're left with a half times 1 over 2x plus 3 times 2. Well, the 2's just cancel, and you're just left with 1 over 2x plus 3. So this next part is a follow-on from the first part, where you're told that we've got a part of the function between a and 0. And the shaded region has an area which is equal to the natural log of 3 square units. Find the value of a. So the area of a function which is h prime of x is equal to the natural log of 3. Well, the integral of that derivative is just the original function, which is, and that is between a and 0 is equal to natural log of 3. So we're going to have 1/2 of the natural log of 2 times a plus 3. I can just put the half on the outside there. So that was substituting a in for x, and now what we're going to do is substitute 0 in for x. Minus 2 times 0 plus 3, so minus the natural log of 3. So what I'm going to do here is I'm going to combine two rules. We know that the natural log with the same base, because the base here is e, inside here of that minus that is just equal to the natural log of 2a plus 3 all over 3. And I also know, using my other rule of log, that that multiplied by this whole thing is equal to the natural log of 2a plus 3 over 3 to the power of 1/2. Okay, now what I'm going to do is I'm going to shift it to the side. But you've got one natural log equal to another natural log, so therefore 2a plus 3 over 3 to the power of 1/2 is equal to 3. If I square both sides there, 2a plus 3 over 3 is equal to 9. Multiply both sides by 3. 2a plus 3 is equal to 27. 2a is equal to 24. A is equal to 12. And that is that.